Okay, so now we're going to talk about the centers of triangles and what happens at the center of each of these special triangles. And to me, this is the coolest thing in geometry. I think triangles and how they relate to circles are one of the most amazing things in math. So we're going to talk about the circumcenter and the incenter, but first we need to know about it, right? So the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. Okay, so this is a big deal. So they intersect at one point. The circumcenter is always equidistant from the vertex of the triangles, from the vertices, plural vertex, vertices of the triangles. So here's what that means. The perpendicular bisector is, remember, it's got to have two jobs, perpendicular and it bisects. So if you look at FP, if you drew a line all this way, and you know it's perpendicular and it bisects, right? And then if you did it to this other side, so let's make this the middle point, and if you drew it all the way down there, and that's a perpendicular bisector. And then let's say, here's the third side, so if I drew a straight line and it bisects right there, and it's perpendicular, all of these will meet at a center, and that's P, okay? So if you drew a straight line, that's what it would look like all the way through, but here, they just kind of stopped on the paper and said, okay, where do they all come together? Well, they come together here and form P, okay? So it's splitting this segment in half, splitting it in half, and it makes them perpendicular. So the perpendicular bisectors are PF, PE, and PD, because those are the guys that are perpendicular and split it in half. The circumcenter is the point of concurrency. It's the point that they come together. So the circumcenter is going to be point P. And then all the congruent segments, well, you can list those. You can say that AF is congruent to FC. You can say that EC is congruent to EB. And you can say DB is congruent to DA. But here is what is really, really cool about a circumcenter. If you know that they are equidistant from the vertices, this right here, this is equidistant, this is equidistant, and this is equidistant, okay? They're the same distance. If you were to imagine and take a compass and put the pointy end on the circumcenter, and you drew, and you have a radius right here, if you took that compass and you went all the way around, this would be perfectly inside a circle. It would make a beautiful circle with all of those around. So when you think about circumcenter, here's the visual. The circumcenter is the circles on the outside of that triangle, and that's the center, okay? So, and this is mathematically what it means, the parts, the pieces that we can say. So that's circumcenter, and now let's see what happens algebraically when we talk about triangles in our practice. So the implications of that in a triangle, here's what that means. If Z is the circumcenter, so right here, of TUV, so that means that this is an angle bisector, this is a perpendicular bisector, and this is a perpendicular bisector, and it cuts everything in half. So that means if this is 34, this is going to be 17, this is going to be 17. If this is 19, this is 19. And, well, we'll take a look about what else it's asking. So TU, this whole length is going to be 38. VY we know is 17. UZ, okay, so look at this, UZ. I don't know the length of UZ, okay? All I know is that one of these legs is going to be 17. But I do know that if this is 21 from the circumcenter to the vertice, if this is 21, this length right here has to be 21. So ZU is going to be 21. Because remember, circumcenter to the vertice, those are all the same length. That's how I'm getting 21 there. Now it's asking me WV. So WV, this length right here. Well, I don't know anything about that. But I do know that I have a right triangle. And in this right triangle, here's a leg and here's a hypotenuse. Am I able to solve for that leg? Yes, it's a right triangle Pythagorean theorem. So remember what Pythagoras said. He said take the square of the legs, so 15 squared plus x squared is all going to equal 21 squared. So I'm just going to tell you that it is x squared plus 225 equals 21 squared is 441. So when I subtract 225 from 441, I get 216. And then x is going to be 14.7. I'm rounding to the nearest tenth. So WV is going to be 14.7. And now it's asking me TV. Well, TV is this whole length. So if this is 14.7, this is 14.7. So when I add 14.7 and 14.7 together, I get 29.4. So that's how circumcenter works. Let's look at number 3 and do that one together. And again, if you want to pause this, figure them out on your own, and then come back, do that too. All right, so I know that the perpendicular bisector is 14. So that's perpendicular. It's 31, so this is 31. I know that this one is 23. I know this is 30, so this is 30. All right, so let's take a look. So GI, where's I? So G to I is going to be 60. M to H, well, if this is a leg and this is a leg, 14 and 31, am I able to find MH? Yes, because this forms a right triangle. So Pythagoras said that 14 squared plus 31 squared is going to equal x squared. So when I do the math, I get, if I did that in my calculator, 14 squared plus 31 squared, I get 1,157. And when I take the square root of that to get x by itself, I get x is equal to 34. So MH is going to be 34. IK is right here. So again, remember these are equidistant. So if this is 34, I know this guy is 34 from the vertice to the circumcenter. And now I have another right triangle. And remember what Pythagoras said, square your legs, 23 squared. Here's a leg, so that's plus x squared, and that all equals 34 squared. So when I do that work, I get x squared plus 529 equals 1,156. Okay, and then I get x squared equals 627, and when I take the square root of that, I get x is going to be equal 25. So IK is going to be 25. HI, so if IK is 25, this is 25. So HI is going to be the whole length, which is 50. And MG is, remember, from the vertice here, it's going to be the same length from the vertice here. So if this is 34 and this is 34, MG is also 34. Okay, so that's how your circumcenter works. And in the next video, we're going to talk about incenter.